Hey, hi everyone. I hope you all are doing good. So, it has been quite a time I uploaded a video. So, in my today's session, I'm going to explain about the steps involved in performance improvements of the web applications, or you can say RESTful APIs also. Okay. So, let's start with it. Okay. So, I would like to give a little background and what could be the possible reasons of these performance issues. Okay. So performance issues are the one where the end users will face an issue of latency basically. Say they want to perform, they want to submit a form. Okay. So when they click on that submit button, ideally there is a SLA associated with each transaction or each functionality in your web applications. But somehow the SLA is breaching. Okay, so for example, if I click on submit button of a form, in 5 seconds it should submit the data, but that is not happening. It's taking more than 5 seconds, and this is irritating the end users. Okay, so that's why they will end up in creating tickets. They say that we are facing an issue of latency whenever we are submitting some forms or whenever we are performing some functionalities. Okay, so this is the basically an issue associated with the performance. Okay, and also there is other scenario when you are trying to develop an application or product from scratch. Okay, so the initial objective will be that yes, we have started covering more and more functionalities for the MVP release. Okay, for the product's first release, which we call the minimum viable product release, that's the MVP release. And usually it happens that even the business wants to introduce more and more functionality for their first release which can be used by their users. Okay, but it happens that sometimes we are so much concentrated on functionalities, somewhere we lose the track and we don't basically look through these performance related issues. And when it reaches to the customers, not all functionalities but some functionalities, they will start getting this kind of latency issues and they will start complaining about it. Okay, so again the team will go through what happened through those functionalities. They will analyze and then they will try to improve the performance. So that's what I'm going to explain today, how we are going to improve the performances. Okay, so first step, identify the modules which are taking more time than the expected SLA. Okay, most of the time this is raised as an issue from the customer side, saying some XYZ functionality is taking more time to complete. Okay, or your QA team complaining about this if your application is not yet in production. Now, launch the application in an environment where the issue is happening and monitor the browser dev tool like network tab. Basically, in most of the modern web browsers, we find that. Okay, so one example I have taken, which is of my.visualstudio.com. Okay, just an example. I think this is the website created by Microsoft, and you can see it has yielded uh, good SLA time. Basically, none of their APIs are exceeding, okay, 5 seconds value or 10 seconds value. They are not exceeding more than 5 seconds. See, all are within the 5 seconds. Okay, so this is just an example I'm taking. Okay, so what you have to do is you need to launch your dev tool like network tab in your browser console, and then what you have to do is basically identify which particular call is taking more time, or which calls are taking more time, or which are breaching the SLAs. Okay, so what happens is when you go through this traffic, okay, for that module or that functionality, you will find that there will be some APIs which basically taking for example, in my case, I have kept a SLA of 5 seconds for most of the API operations. Okay, so what I will do is basically I will simply check which API is exceeding 5 seconds. Okay, so if there are some APIs like 2 or 3 APIs, just for an example, which have exceeded the SLA by taking more time, like 10 seconds, 15 seconds. Okay, then what I will do is basically I will list out those APIs. Okay, and then I will start the investigation. So that's what I have told. The most important column as highlighted in red color is time. Just observe which APIs has resulted in taking more time to return results than expected SLA as per the service contract. Okay. So we usually write service contracts and we share those service contracts with our customers that boss, I have written a service for you and this will fulfill your requirement within this amount of time, which is called the SLA. Now, capture the complete API URL from the headers tab. I think in the same browser's network tab, okay, what you can do is quickly click on the API or APIs which were taking more time and check the headers tab. You will find the complete URL. Just copy that URL. Okay. Now locate those APIs one by one in your code base and start the process of improvement. Okay. So what are the steps? How are we going to improve? That I will explain in a while. And also for desktop based applications, please use the tools like Fiddler, guys. Okay. Fiddler has a wonderful feature called snipping kind of, or what I can say. Okay, a spy kind of, sorry. It's a spy kind of button is there in Fiddler tool. If you select that spy button, okay, if you drag it and drop it on your desktop application, it will immediately start capturing all the traffic associated with your desktop application or thick kind application. Okay, so yeah, you can make use of Fiddler to identify which APIs are taking more time in order for a desktop application. Okay, so that's it. Now, first thing, what we have to do the moment you identified the APIs which are taking more time, then you start the analysis one by one. Okay, and now how the process of improvement starts. First, you have to check, okay, in that API's service layer, are there are there any unwanted table joins? Okay, are there any unwanted tables in your SQL or LINQ joins? LINQ is a C sharp technology. Okay, so that's what we need to check. Okay, so uh, this scenario I can tell you, okay, how this particular issue is introduced. Okay, so you were implementing a requirement at its initial phase. Okay, so you have implemented an API, okay, at its initial phase of requirement where you were required to query three tables in order to get data from all these three tables. Okay, but later business decided that they don't wanted some information basically from any one of the table. Okay, from out of these three tables, from one table they don't wanted any information. Okay, so what happened, they refined the requirement, okay, and they created a story for it. Okay, now what happened, from the front end side, what happened, the front end team used only that information the API returned basically. Okay, so what front end team did is basically it only extracted the information needed for the two tables, but it didn't extract the information from the API which is no more used now as per the new requirement. Okay, so from UI side I think they corrected the issue, but from the API side still what's happening, basically your LINQ query or SQL query is still making use of that unwanted table in your join. Okay, which is basically increasing the number of checks in terms of that on condition. Okay, so let me demonstrate that quickly. So I have a, okay, for the sake of saving time I will write the query quickly and then I will start. So I have quickly written a LINQ query. You can write the equivalent SQL query also. Okay. So with the initial requirement, see, look at this query. So what it was doing, it was extracting user details from users table. It was extracting report from reports table. Okay. On user selected report ID matching with the reports ID. And then it was also extracting the report detail from report details table with report ID matching report detail ID. Okay, where user.id is equal to the supplied value whatever it comes from the API. Okay, or from the front end you can say. Okay, whatever they said. Now the customer decided that, or the business decided that they don't want this approver detail needs to be shown. in their UI or in their API itself, for example. Okay, they don't want this information needs to be revealed there. Okay, so they gave a requirement, just return users ID, users name, report ID, report name. That's it. Okay, so due to mistake, or I don't know, either the UI team, when the story came, what they could have done is simply they discarded the approver column or the approver property from the result set which was returned from API, and maybe they implemented only considering these values: ID, name, report ID, and name, which worked very well from the UI side. But there is a problem. Okay, there is a problem from the API side, because the API team has not removed this report detail table from their query basically. Okay, so this may cause a huge problem, guys. Okay, just imagine if these tables have millions of records. Okay, and you know that now this table is no more required in order to extract any column from that table. Okay, then what happens is you will end up in doing extra condition checking. Okay, you will end up in doing extra record extraction and checks or condition check for these tables. Okay, in order to just get the data which comes only from these two tables. Okay, that's why this is a redundant table, and this may increase your queries execution time. Okay, so always remember, as I explained in my PDF. Okay, one cause or one reason or one check you need to always verify is check if there is an unwanted table is still there in your SQL or LINQ queries. Okay, so what is the fix here? Okay, I did a mistake where report detail ID should be. Okay, yeah, now it makes sense. Yeah, so now I'm no more making use of this report table itself in my API. Then why should I keep it in my join? Simply remove this. That's it. Okay, so it is pretty simple. Whatever data I want, it is coming from user and report table. I'm checking for the user, and then simply what I'm doing, basically I'm extracting the details. Okay, so this is a trivial example. Usually you won't check for a single value. There is a possibility that your where condition may include multiple checks. Okay, there may be a list of and conditions basically. Okay, you will check one condition and this and this and that, like that. Okay, in real world applications, okay, or in your existing production applications. Okay, the queries are not always so simple, guys, because you will be doing a lot of complicated processing. A complex processing would have taken place, and you must always ensure that whenever some table is not required, okay, in your API, sorry, in your query results, okay, always ensure that you remove such unwanted tables from your joins. Okay, so I hope you people understood the significance of removing unwanted tables from your joins. Okay, simply uh, simply you are basically removing unnecessary processing which you are basically introducing, and that data is also not required from that table. Okay, so that's it from the first point. I hope it's clear for you people. So let's move on to the next one. So what does the next point says? Too many DB calls, either using ADO.NET or EF core library. Very interesting point. Okay, so what happens is usually when you have created your own data access layer using ADO.NET layer, or maybe you are making use of entity framework. Okay, what I have seen is the thing which can be achieved with one query by introducing joins. Okay, for the same thing, what people do is first they will extract, okay, each and every table details, and then they will apply the joins. Very bad practice, guys. Okay, basically you are introducing a lot of network calls or DB calls basically. Okay, if you are in most of the real world applications, your database is not on your local machine, it will be hosted on a remote server, right? So in order to get each and every record, okay, you have to establish the connection, the network connection, and get the results. Okay, this will increase a lot of network communication between your application and the database. Okay, so let me show you that example. Let me write the code snippet. Okay. So I have constructed a small code snippet in order to demonstrate this too many db calls. Okay, so what is the problem here? See, first of all, for a given user, what we are doing, we are extracting the user's record from database. Okay, and then what we are doing, again we are making use of this repository pattern, and what we are doing, repository, from repository we are extracting all the reports which are associated with this user. Okay, and then what are we doing is using a for each loop. Okay, we are iterating over these reports. Okay, and then for each report, again we are ending up in making one more db call. Okay, in order to extract the finance report summary. Okay, some other information basically required from this report detail. Okay, so using that report id, and we are extracting this particular information. So can you see what is the problem here, guys, in entity framework or in any technology, equivalent technology? Okay, so the problem over here is, okay, first thing, this could have been achieved with a join. Okay, that we didn't do. Okay, first thing, it will make one db call. Okay, this will end up in one database call, this will end up in another database call. Okay, when it is used here, because in entity framework core, okay, we usually our report repository should end up in returning a I queryable instance of your entity. Okay, so when this reports is basically invoked from this for each loop, okay, first db call is over here. Okay, I extracted my user data, user information, okay, by making this call. Okay, and then this is the early execution in entity framework core, because I called the first immediately. I want the first record which matches my user supplied users id value here. And then what I did is, using a report repository, I made one more call. Okay, where I'm extracting all the reports which are associated with this user. Okay, so when this for each is executed, basically this query will fire. Anyway, I fired two queries. Okay, one for here, one for here, which I could have achieved with only just one query by making use of a join. Okay, this is the first mistake. Okay, then if you see here, what I'm doing, using a for each loop, I'm iterating over each and every report, and again I am doing one more database call in order to get the finance report summary for that report. Okay, now, in a development environment or QA environment, if you have a very minimal data, okay, or yeah, database, I can say, okay, the volume of data in your dev or QA environment is very less. Okay, this may cause a very little problem or no problem, I can say. You can't see the impact, but the moment, okay, in your UAT or in your production environment, if this kind of code enters, and if the data volume for these tables like users, reports, finance report summaries is in millions, basically, if these tables have millions of records, guys, this will introduce a huge bottleneck. Okay, you have introduced a very critical performance issue. Okay, if your report table, okay, if your report table has millions of records, and for one particular user there are, if there are, say, a very minimal value I am taking, even if there are 100 reports are associated with your single user, what will happen? Okay, you will end up in making 100 database calls in order to get the finance report summary. Can you see this here? Gone, your performance has completely gone here. Okay, so we should always avoid this kind of approaches. Okay, never do a lot of DB calls. Okay, in order to get a piece of information, because the same information you could have extracted using a simple join. See here, this join will work out for me. Let me quickly bring it up. Okay, this is the first step of improvisation here. For the above two queries, instead of firing two queries, okay, first thing, I can get that result in one query, that is this one. Okay, now What about this for each? What about this call over here? What I have to do is, okay, instead of going by one report and for each report making call to your database, what I would prefer over here is I will put this line above, okay, say for your finance report summaries I can call, because what I'm going to do is instead of making millions of call, I will simply extract the result at one shot, only in one call. And how I do that? Basically, simply copy and paste here. Okay. Now, instead of passing just a report ID over here, what I will do is I would say I will introduce a method in my repository, okay, which returns a list of reports for the supplied IDs, basically for whatever information I supply in list. So simply take this. I would introduce a method something like this. Okay, get final report summaries, and here what I do is basically Control C V reports dot select. Okay, sorry, let me put it this over here. Okay, so with one query I extracted user as well as report information. Now from this result what I will do is result dot select. Okay, say argues r dot report id. Okay, that's it, and get rid of this block only now. Okay, instead of going through each and every report, getting the finance report summary for that report id and then doing some big processing. Now first you cache everything basically. Okay, first you extract the user as well as report detail, and then using this query result you get all the reports id at one shot, that is over here. Okay, and pass it to a method in your repository which accepts a list of ids and then returns results for all those supplied input. Okay, so instead of doing millions of calls for millions of reports or hundreds of reports, now you are just getting all this required information in one query. Okay, see, you improved the performance basically. Okay, now with this cached or buffered record set or result set, now you do whatever you want to do. Okay, you run over this number of records, you construct any object you want to do, you do whatever processing you want to do. Okay, you simply do it over here now. That's it. Okay, I will say FRS, and on this FRS, now it's up to you whatever processing you want to do it over here. So no need to do any additional DB calls, nothing. You did only everything in two shots. First one, you extracted the supplied user's user ID, and for that user ID, you got all the report IDs. Okay. And then what you did is you extracted all finance report summary for the reports, okay, for each and every report which was associated with this supplied user basically. Okay, so this is how basically you should improve the performance by not making unnecessary database calls. Guys, the same thing will apply for proxy calls or the REST API calls. Suppose if your API or your web application is making use of some other REST API or a external REST API, in that case also always remember, don't do for each and every record, don't make a API call, external API call. Instead, you get the details like this. Okay, let me quickly show that over here only in order to cover that also. So what I will do is suppose var I would say report details, or I would say no report detail, I would say get lab details, because this is an external service which gives me lab details. It's just a hypothetical examples, guys. Okay, so get lab details, and what I do is underscore proxy, or your http client based service, you can say underscore proxy lab service, which makes network calls. Okay, lab service dot get lab details, and you simply pass the report id. That's it. That's it. Okay, so what happens is, now get instead of getting one lab detail at a time by iterating over this collection, now what I'm doing is basically this external service has given one more API for me. Okay, there are two endpoint, one returns only one lab details, and there is one more API endpoint which returns a list of lab details for provided list of report IDs. Okay, in your case it will be different, it will maybe a different business domain, but the overall idea I hope you people are understanding here. Okay, my overall goal is to get all the data at one shot instead of iterating over a loop and getting it one by one and introducing a hell lot of performance issues or a lot of network calls. Okay, now you do whatever you want to do with this collection inside your loops. Okay, so this is the basic idea. So don't end up in making a lot of network calls or database calls and hamper the system performance. Always look for the opportunity, always see for this opportunity. Okay, so okay, whenever you have this premature information, in my case, see, from this query I came to know that this is the report id I should use in order to get the finance report summaries, okay, for my user. So what I did, that I had an opportunity over here, so I extracted all the reports associated with my user and I passed all those report ids to you, to my repository method, which accepts a list of report ids and returns me the finance report summaries. Okay, always remember, whenever you design your repositories, okay, or your proxy services or external services basically, okay, always remember there should be one method which accepts a range of input values, and for all those range of input values it should return the responses. Okay, a list of responses. Okay, so that is the overall goal here, and I hope you people understood what I am trying to achieve here. Okay, so let's move on to the next point. Okay, application of two list or two enumerable on queries whose target table have millions of records. Very simple. In my one of the previous videos, I have already explained this, guys. Okay, so just for a quick example, I will show it over here. So report repository. So for the sake of time, I wrote the query. Just have a look at this. Okay, on my report database context, and on the reports DB set, what I did, I immediately called as enumerable, and then I applied my where condition. Guys, this is a bomb. Okay, and same applies to the to list. What happens is, okay, when this particular statement is executed, entity framework will bring all the records in your reports table into your into your server memory or your app service memory, and then it will apply this where condition, which is of useless basically. Okay, there is no point in applying this condition after bringing everything into your server memory and making your app service performance down. Okay, so this is basically and not a recommended approach. Never ever apply this. Okay, if your reports table or any kind of table in your business domain, if it is dealing with millions or billions of records, then just imagine what will happen the moment you apply this. All the records will be brought into your server memory, and you will see an unexpected latencies or application crashes. Okay, never ever do that. The best recommended practice is always use as queryable. That's it. Okay, that's it. If you apply this basically, okay, in entity framework, by default, if you see the reports, if you just try to access the reports, even even not applying this, by default it will return a iQueryable instance. In that case, what happens, basically, uh, this statement will be first translated into a SQL query, and then that SQL query will be executed on your SQL server. So nothing will be brought into your server memory. Okay, the SQL transact SQL statement will be constructed. It will be executed on SQL server or any target database server, and then only the filtered records will enter your server memory or your app services memory, basically in your jar. Okay, so always remember that point. Don't apply toList and to enumerable, as enumerable on any of your DB context DB set classes. Okay, so that is already I explained. Now, trying to achieve complex business logic processing in C sharp, whereas it can be put on a SQL stored procedure. Very important point. I will write a little code snippet for this and I will explain. Okay, guys. So, trying to achieve complex business logic. Okay, so trying to achieve complex business logic processing in C sharp, whereas it can be put on a SQL stored procedure. Guys, always this is the best practice. If you have a very lengthy or a very complex business logic processing, okay, and the recommended approach is that try to avoid it, keeping in a C sharp's business layer. Okay, so don't try to do that over there, but instead try to achieve it in stored procedures. Okay, I think most of us, we already know what are the advantages of using a SQL stored procedure. First of all, you are going to prevent a lot of network or DB call operations back and forth from your application to your database store. Okay, that is the first thing. And this logic, the entire processing logic, will be kept on SQL server side only, and it will be processed on SQL server, so there is no processing load on your app services or on your application server, basically. Okay, there are a lot of advantages, but I am highlighting few of these. So keeping this kind of complex business logic processing on SQL server will always yield good performance. Okay, so that is one thing I would like to highlight here. And parsing of XML and JSON in your API's business layer. Again, see, it has been proven that parsing of XML always takes more time compared to our JSON. Again, in order to parse JSON, that is also an expensive operation. Okay, so it is always recommended that if possible, try to move this kind of XML or JSON parsing on the SQL server side only. Okay, because they have a lot of performance proven APIs implemented in your SQL server databases. Okay, using those APIs, I think you can do all this processing, and try to keep this kind of processing on SQL server stored procedure only. In terms of SQL server function or stored procedure, again I will leave it up to you, but it is always better practice to avoid parsing this kind of data structures on your business layer. Okay, then comes, instead of getting a list of results from external service at one shot, I think I have already explained with the point 2 only. Okay, so instead of getting a list of results from external service at one shot, making call to service on each iteration. This is basically a bad practice that I have already explained. Always design your APIs in such a way that apart from returning a single entity or a single domain object, you should introduce APIs which will return a list of domain objects for the list of supplied identities, or the IDs, I can say. Okay, so this also will help you to achieve good performance. So you won't end up in calling your external service each time in order to get each your domain object, each one of your domain object. Okay, so you can prevent that by implementing this kind of APIs, which will return all the requested domain entities at one shot. Okay. Then comes is the smell of nested for each loops. Always remember, if you see in your code base there are nested for each loops or for loops, always remember that there is an opportunity to achieve the same result using SQL joins or LINQ joins. Okay, always remember this, because basically you are doing the same thing using these loops, which is not at all a recommended approach. Okay, And also you should know the complexity of this kind of using two for each loops. Okay, so if you are making use of two for each loops, so it will come to a complexity of n square basically. Okay, for each variable, for each iteration of your outer for loop, you will iterate your inner loop for n number of times. Okay, so always remember, it's a n square complexity. Never ever try such kind of things. Okay, try to achieve the same results with the joins. Okay, so well, that is explained, and then we will move on. Not making use of asynchronous APIs. Okay, in EF or EF core or the HTTP client provided asynchronous APIs. Again guys, always remember, most of the most of the database operations or network operations or external service invocation operations, it is always a recommended practice that always try to achieve them asynchronously. Okay, and most of the programming APIs nowadays, they are introducing the asynchronous version of their functionalities. One such example of EF or EF core is that to list async, save db changes async, okay, delete async. Like this, they have introduced a lot of asynchronous version of their API. So please make use of such asynchronous APIs in order to achieve good performance, because in case of asynchronous, the processing will happen on a secondary thread or a background thread, thus achieving a maximum level of parallelism over there. Okay, so that is the point I would like to highlight here. Always try to make use of asynchronous APIs. Okay, then instead of making use of, again, one more mistake that we commit is, instead of making use of queries relying on, oh sorry, instead of making use of queues or message queues, okay, relying on REST APIs for the functionalities which don't require any replies or reception. Okay, so just uh, consider a scenario. Okay, you want to subscribe for a service. Okay, you want to subscribe for some product on a e-commerce site. Okay, what you do, you will usually go there and you click on the subscribe button provided by them. That's it. Okay, they will ask your email ID, you enter your email ID and click on subscribe. That's it. Forget about anything, don't wait for any notification. Okay, whenever the product is available, okay, the e-commerce website itself will notify you that, boss, this particular product is available and you can buy it. So what I'm trying to explain is, this is one common mistake I have seen in our microservices architecture or RESTful architecture. Okay, wherever there is an opportunity to make use of asynchronous programming by using message queues, we simply write REST APIs and we unnecessarily introduce a lot of delays. Okay, so we can avoid that simply wherever you find an opportunity where you don't require any immediate reply. Okay, it's kind of fire and forget, I can say. It's called a fire and forget pattern. Okay, so basically you want to do something, you want to process something, and what you do is you simply put a request for that processing and you forget. Okay, once the service or the responsible service, I can say, which is meant for reading these messages and processing, once they complete the processing, they will only let you know that, boss, you had put a request for this and we have completed the processing, and yes, you can go ahead with further processing. Okay, so make use of message queues in order to achieve asynchronous programming, or I can say serverless programming, okay, in a precise manner. Okay, then what is the other mistake? No implementation of caching for data which changes very rare. Okay, in most of our business applications, or you can consider any business domain, we will always end up with some data which is called master data and which changes very rare. Okay, it's kind of static, it won't change a lot. Okay, and what we have seen in most of the yeah, in most of the applications is that people have not implemented caching for such data. Okay, instead, for each and every time whenever the data is required, they simply make the REST API call or they make the database call in order to get it back and forth. Avoid that, guys. Simply make use of caching. I think caching has been provided as dominant or prominent feature in most of the programming frameworks. Okay, just make use of the caching and cache such master data in order to avoid unnecessary network or DB operations. Okay, this will also help you to achieve good performance. Okay, you will not end up in making a lot of DB calls or network calls. So that's it. That is it for the caching of data. Now, what is the other mistake? Keeping entire application data in one database, resulting in busy DB. This is also one common mistake which happens in the database design that I have seen in my career. Okay, while the design of the database itself, basically they design everything properly. I think if I see the relationships, okay, if I see the table structures, if I see the what is that, mappings, everything is correct. But the actual issue comes when everything has been kept into one database itself. No, we should avoid this, guys. And when it comes to microservices architecture, this is completely prohibited. You should never keep your entire application data into one database. Okay, each and every microservice is responsible for accessing its own database. So you have to split these responsibilities when it comes to databases. Okay, always distribute your application data, okay, or your database tables in such a way that they are domain driven. Basically, it's called DDD, domain driven design. Okay, every domain, every subdomain of your application should be kept into a separate database, and for that separate database always try to implement a microservice or a REST service. It's up to you. Okay, and yeah, and try to achieve most of the database operations. Okay, so the problem is that if you keep each and everything, your entire application database tables and data in one DB, it will basically make your database very busy. Your SQL server or any database management system will be busy with performing most of the operations with a single DB only, which may introduce an additional latencies basically. Okay, just to avoid that, always try to distribute your application database tables across multiple databases. Okay, by that approach, I think you can avoid the problem of busy databases. Okay, in case of microservices architecture, I think it is in the design itself, and nobody will keep everything in one database. They are always distributed, domain specific or subdomain specific most of the time. Okay, so that is said. Now, retry storms in microservices. Okay, so in my previous videos, I have already explained the retry mechanism when it comes to the databases basically, or the database connections. Okay, so the problem with the retry storms is that if you don't specify a predefined number of retry attempts, for example, I will say that if due to connection resiliency, if I lose my database connection, I will try it for 3 attempts or 5 attempts. I will specify the number of attempts basically. Okay, and then my service will try for 3 to 5 attempts, and if it is not able to access, then it will leave it. Okay, but in some of the applications, it has been seen that if an target database or a target RESTful service or a microservice is down, then the source service is keep on retrying, sending requests to that service. Okay, which will result in retry storms. Okay, and this retry attempt will never end. Okay, it will keep on retrying. So we can make use of the circuit breaker pattern in order to avoid this kind of retry storms. As I already explained, the number of attempts I'm going to try, or at least if for some attempts, if all of my calls are getting failed, then it is better to tell the service that don't try any more attempts until and unless that service is up and running. Okay, and I have seen a pattern in most of the microservices where they introduce a specific endpoint called keep alive. Okay, a very simple endpoint in a microservice. Okay, what it tells is whether the service is up and running or not. It will simply, if it is up and running, it will simply return true. Okay, or you will be able to access that service. If it is not up and running, basically you won't get anything. Okay, or at least you will get a boolean value of false, that some part of that service is not working as expected or it is under maintenance. So you can stop trying any kind of such service requests. Now we will go to the next mistake: no implementation of lazy loading, both front end and back end. Guys, lazy loading, if used properly, it will boost your application performance, because in our enterprise grade softwares or any kind of software, usually it happens that there will be some services which are very resource expensive and which take more time when they are initiated. Okay, so there is no point in loading such services when there is no need of that, basically. Okay, there's no point in initializing them and keeping idle. Okay, so what we can do is we can basically implement the lazy loading mechanism. Okay, so you just make them lazy services. So whenever such services methods are called, or that message or that service is invoked, only in that scenario that service should be instantiated or brought into life. Otherwise, just keep it as it is. Okay, don't load it into your memory itself. Okay, so this way you can achieve a good performance. So you will basically, the advantage of making use of lazy loading use that is that you basically won't end up in making use of expensive resources or holding expensive resources for a longer time. Okay, so that is the advantage of lazy loading, and same applies for the back end and also for the front end also. If you are making use of any popular JavaScript frameworks like Angular or React, always consider implementing lazy loading. Okay, in case of Angular, for example, load only those modules which the user is currently interacting with. Okay, and load the other modules whenever there is a need or whenever those modules are activated, basically. Okay, by this, what happens is, with respect to Angular, I'm telling you, your application load time will be very small. Okay, it will be, your application will be started with a minimal number of modules. It will download very minimal number of modules, and it will start the application, and it will load it whenever it needs some other modules. Then only it will load it, in spite of, or instead of loading everything at one shot and making the application making the application startup time longer, basically. Okay, so we should not do that, because for customers nowadays, application startup time matters a lot. When they enter a website address and when they hit on enter key, they should see the home page, basically. Everything should load faster. And if you don't implement this kind of lazy loading, then what happens is your application load time itself will increase, because your browser will spend most of its time loading all the modules in your applications which are not at all used for the first page, or you can say the first module of your application. So that's it. Never commit this mistake. Always implement lazy loading wherever it's appropriate and wherever there's opportunity for that. No implementation of pagination or paged results applies for same front end and back end. Okay, whenever you are reading, whenever you are reading a list of records, okay, or whenever you are trying to populate a table in your front end, always remember, load only paged records. Load only a specified set of records from your backend database or from your service. Okay, don't load everything at one shot to your front end applications. Okay, this will increase a lot of latency, because you are returning all your result to your microservices or for your micro front end or front end application. Okay, so always implement pagination. Okay, always you have to extract a fixed set of records. For example, if you are populating a grid and you are you are populating a grid, then provide an option of number of records per page, basically. It may be 5, 10, 15, 50, like that. Okay, so the pagination should happen only for those records per page. So whenever I'm in a current page, I should show only 10 records. When the user clicks on next button, then you load the another next records. Okay, okay, so this way you can basically avoid the problem of what I can say, okay, the latency in loading the results. Okay, or the latency of loading a web page which is basically showing 10 records, but in the background it is loading everything. No, always implement pagination or paged results. And one more thing I have seen, I can't say minimal impact, but always try to avoid using parse or toString methods in your LINQ where conditions. Okay, I will tell you what happens is, if your table has, say, if your table has million or billions of records, then for each combination you will keep on performing parse toString or any helper kind of utility which is available in your framework. Okay, try to avoid these things. Okay, when you are sure that your left hand side of the equality operator and right hand side of the equality operator are with the same type, then why are you going to perform this kind of toString or parse? Okay, always keep them in a same data type and try to achieve these conditions. Okay, never ever try this, because this will add additional performance impact. Okay, I hope you people have understood how we can improve the performance. I have given a I have basically listed out a list of mistakes or bad practices that I have usually seen in my career, and I have corrected them basically. So I hope this will help you to achieve the performance or correct or improve the performance of your applications which are basically struggling with poor response times or performance basically. Okay, thank you for listening and have a nice day, guys.